Kirk math. All right, ladies and gentlemen, here we are. Topic 9, our last topic. We are going to start 9.1. We're looking at solving quadratic equations using tables. I believe we're on Student Companion page number 191 and 192. Okay. All right. Okay, so we are starting to look at quadratic equations, which are very closely related to quadratic functions, and we need to find solutions of these equations. So while we're working on this and while we talk about the solutions of quadratic equations, I want you to think about the connections between the graph of the function and the solutions to the quadratic equation. What evidence can you give so that the x-intercept is the solution of a quadratic equation? So we know that the x-intercepts of a graph or of a equation are the solutions to the quadratic equation, okay? So when we come down here, we're starting to look at these functions, right? So they took a function and they made the function equal to 0. And that is because it is turning it into an equation. See how we now have no function notation? A quadratic equation is an equation of the second degree. The related function of a quadratic equation with 0 on one side is the quadratic expression given on the other side. So basically, a quadratic equation is just a quadratic function that is equal to 0. And this quadratic equation does not have a b. Basically, their b is 0, so that's what's kind of special about it. However, the y is 0. And now, if we're going back to what we were asked to think about on the last page, why would that mean, if y is 0, then why does that mean that our x-intercepts are our solutions? Well, when y is 0, that's when we find x-intercepts. So solutions of a quadratic equation are the values or values that make the equation true when y is 0. Okay, and so that's what we're looking for with these quadratic equations. Here in our graph, this equation right here, x squared minus 16, when we graph it, we can see that the y-intercepts of f occur twice, okay? It crosses the x-axis twice, which means that our solutions are -4 and +4, okay? When solutions to an equation in the form f of x equals 0, so basically when we have a equation when its equal set to 0, that's called the zeros of a function. It corresponds to the x-intercepts of the function because it's when the solution is equal to 0, when y is 0. All right, so here we go. We're going to take a look at this equation right here. This one has a b, which is -14x. Whoops. So we're just going to show you here, if I graph this, it only touches the x-axis once. It doesn't cross over it. So there's only one solution, which is x is equal to 7. If we look at this example, x squared plus 3x plus 7 is equal to 0, you can see that the graph does not touch the x-axis, which means that there is no real solutions. So a note here to write down is that a quadratic equation can have 0, 1, or 2 real solutions. Those are your options, okay? So it cannot cross the x-axis, it can touch the x-axis but not cross it, or it can cross it and have 2 solutions. All right, so the first try it problem in your student companion, we're going to do together in 2 different ways. So the first way that I did was by graphing, just like we did on our previous lessons. I know that there is no b, so I made it 0, okay? And I basically created my negative b over 2a, but with b being 0, x is going to be 0. So I know that my x axis here, or sorry, my axis of symmetry and the x value of my vertex is 0. I plugged it back into my equation and got -36. So my vertex is at 0, -36. Then I plugged it into 2 numbers. I plugged it into 4 and I plugged it into 6, and I got 4, -20, and 6, 0, 6. Sorry. 4, negative 20, and 0, 6, 0. Which means that 6, 0 and negative 6, 0 are my solutions. So negative 6 and 6 are the solutions of this equation. And for a better graph, oops, let me show you this. Here's the graph on Desmos so that you can see it a little bit better. Okay. Now, if I don't want to go through all of this work, there's actually a faster way to do this, which if you do not have a b, you can just solve this equation, solve for x. And so to solve for x, I'm just going to go ahead and add 36 to both sides and get x squared equals 36. Do the square root of both and get x is equal to positive 6 and negative 6. And that's it, you're done. That's my solution. So when graphing or when solving these quadratic equations, if you're missing b, you can just solve, especially if it's just a perfect square, or you can graph like we did previously. So you're going to go ahead and try this. Try it right here. I want you to go ahead and solve. Because there's a b here, you're going to need to do it by kind of graphing, find the vertex, and then 5 points on the side until you can find where it crosses the x-axis. All right, another way to solve these problems would be to use a table. So if I have a quadratic equation and I set up a little H chart like this, I'm going to pick values for x. You can use negatives, positives, but or sometimes they give you the values. Here we're just going 1 through 6, and we're plugging them into our equation and finding the value for y. Our goal is to find 0. Okay, sometimes they work out really beautifully and you can find those zeros really easily. And I know that the solution to this one is 1 and 6. I can also identify my vertex is in here because I am decreasing here from 1 to 3 when x is 1 to 3. And then I start to increase again when x is 4 to 6. And so as soon as I make that switch from increasing to decreasing or vice versa, I know my vertex is in there somewhere. Okay, but to solve, it doesn't always work out perfectly. You can't always find 0. So sometimes you have to estimate the solution, okay? So here in this table, we're going to follow these steps right here to estimate our solutions. Now you can see already that we identified one solution as negative 2, and that's actually our first step here, is finding the first solution. All right. So the first solution was identified in the table as negative 2. To identify the second solution, we have to look for a change in y values, okay? So as the x values are increasing, as we're going consecutive x values, when a y value goes from one sign to the next, that's a signal that there is a 0 in there somewhere, okay? So on my chart, you can see that I go from 0, negative 4, negative 2, 6, positive 6. That means that there's another 0 in here between 0 and 1. That's my interval. So now I'm going to refine my interval. I'm basically going to dive deeper between 0 and 1 and start to find the y values using steps of 0.25. So that's what I did up here, was I started to break down between 0 and 1. I have 0.25, 0.50, 0.75, and then 1, and I filled in a table. And what you might have noticed over here is that I never actually found 0, but I did find two numbers that, again, are very close, so I know that it's between these. Okay, so that basically is me approximating my solution. I'm not going to get an exact answer, but I can identify that my other solution is between 0.25 and 0.5. Using a table like this has limitations, especially if you're not able to use some sort of graphing calculator or online program to, supercomputer to find the exact answer. If you're doing it by hand, you're going to have approximations, okay? You're not always going to figure out when y is exactly 0. but you can estimate it. So what I need you guys to do now is to basically approximate your answer for this solution. So you have your problem here, the 4x squared plus 3x minus 7. And we're going to go ahead and put that in my table. So this is my equation I'm going to use, 4x squared plus 3x minus 7. And I gave you some intervals here. These right here, the -2 through +2, are always good ones to start with because you don't know where you're going. But when you're filling out a table like this, you're going to kind of have to adapt. If you do -2 and your answer for y is nowhere near 0, you might need to adjust your numbers. But if you do -2 and it's really close to 0, you can keep going up or down depending upon how close you are to 0 and where do you think you need to go. But I'm going to do the first one with you just to kind of show you what you're doing, but then I want you to fill out the rest of the table and see if you can find those zeros. Remember, when you start changing, your y's change signs, you're going to isolate those two numbers and then dive in deeper like we did on the previous page here, and try to find that 0 to the nearest tenth. And that's what it says here is if you're approximating, find the answer to the nearest tenth. Okay, so for this guy, I'm going to do 4 and then 2 squared, or -2 squared because I'm using this x, plus 3 times -2 minus 7, and I'm going to calculate that out. So this is going to be a 4 times 4 is 16, plus -6, so that's 10, take away 7 is 3. So if x is 2, y is 3. All right, and then you go ahead and do that for the rest of the numbers and find your values of y. Find the y values. Find your solutions when y is 0. That's your goal. All right, quick concept summary here. A quadratic equation can be written in standard form where a is not 0. A quadratic equation can have 0, 1, or 2 real solutions. Zeros of the function related to a quadratic equation are the solutions of the equation. In algebra, you have an example here where this quadratic function is made equal to 0 to make it a quadratic equation, and its solutions are -4 and -1 because those are numbers that when I plug in, so when x is replaced in here, -4 is replaced for x, and -1 is replaced for x, they equal 0. On a graph, we know what the solution is because it's the x-intercepts. It's where the graph crosses the x-axis, if it crosses. And in a table, we know where the solutions are because we're looking for that y value to be 0. But remember, using a table is not super efficient and accurate. Sometimes you have to approximate. If you cannot find your zeros, you might need to dive in a little deeper and start going into hundredths, 25 hundredths, 50 hundredths, until you can find something as close to 0 as possible. All right, good luck.